Let's solve an IMO problem, 2021 problem number 4. Let ABCD be a quadrilateral with an inscribed circle with center I. Draw a circle passing A, I, and C. Extend BA and BC intersecting the circle again at X and Z respectively. Extend AD and CD intersecting with the circle again at Y and T respectively. 8 segments are created in the new circle. 4 of them form a quadrilateral, ADTX. The other 4 segments also form a loop, CDYZ. We need to prove that they have the same circumferences. The segments on the left-hand side of the equation are colored blue, and the right-hand side are all in orange. I'm going to do some manipulations of the equation, but I will follow this color convention. We label the tangent point of the quadrilateral ABCD with its inscribed circle as P, Q, R, and S. This will be our starting point. The key technique is the two-tangent theorem. For example, from the point A, we have a two-tangent segment AP and AQ. They have the same length. Looking at AP and AQ in the bigger picture, AP is a part of AD. It is blue, meaning it is on the left-hand side of the target equality. I'm going to replace AP with AQ. Now AQ is blue. From the point C, we have two tangent segments, CR and CS. This time, CS is orange, meaning it is on the right side of the equation. We replace CS with CR. Now CR is in orange. From the point D, we have a two tangent segment, DP and DS. DP and DS are on the different sides of the target equation. I switch their side, means I change the color. It is indeed a temptation to remove them from the equation because they can cancel out. But you will see the reason soon. Now, let's have a quick summary. We have a new target equation to prove. Both sides contain 3 segments. QX, XT, and TS on left-hand side, and PY, YZ, and ZR on right-hand side. As a matter of fact, this equation can break it into 3 parts. First, QX equals PY. Second, XT equals YZ. And finally, TS equals ZR. It seems too good to be true, especially for an IMO problem. But we are going to verify these 3 equalities. We have 2 congruent triangles, IQX and IPY. When we rotate one triangle around the point X, it reaches the position of the other one. Now, let's look at it theoretically. First, they are both right triangles with right angles at the tangent points P and Q. Secondly, they have a pair of congruent acute angles at x and y. Why this is true? Because these two angles are inscribed angles with the same intercepted arc of AI. So far, we established the similarity of these two triangles. But we also know IQ equals IP because they are the radius of the inscribed circle. So we establish the congruence of these two triangles. As a result, their corresponding side QX equals PY. But the QX and the PY equals PY is exactly the first equality we are going to check. Checked. We have another pair of congruent triangles, IST and IRZ. Their similarity followed exactly the same argument. They are both right triangles. They have congruent acute angles. Both have a side of radius of the inscribed circles. Therefore, their corresponding sides TS equals ZR. And the TS equals ZR is the third equality to check. Checked. Now, the only thing remains is XT equals YZ. We already established two pairs of congruent triangles. Let's look at the first pair. We have a byproduct out of the congruence. Their hypotenuses, IX equals IY. IX equals IY. Let's look back. Let's look at it again. IX equals IY. Another pair of congruent triangles yields the hypotenuse IT equals IZ. IT equals IZ. Now, let's remove everything else and only keep the relevant elements. We have IX equals IY, IT equals IZ. All 5 points are on the same circle. Do you agree that XT equals YZ? Thank you for watching, and please consider subscription of my channel. I appreciate your support.